Hello guys, today in this video I'll be talking about pointers, arrays and structures in programming with C++. My name is Bonsu and I'm glad to take you through this video. Let's begin. Now you can see in our screen over here we have the pointers, but before you go to our main points, we go through some objectives over here. So we have some objectives. So the first one is the introduction to the pointers, introduction to the arrays. Then we have pointers into arrays. We change pointers into arrays. Then we have the reference. Then we continue with introduction to structures. Then we continue with introduction to the unions and introduction to enumeration. Now let's begin with the pointers. Now a pointer is a variable that stores the address of another variable. A pointer is a variable that stores the address of another variable, and a pointer can be used with any data type. As I said previously in our other videos, the data type, these pointers can be used with any of the various data type that we have. Now we move on to the creating a pointer. A pointer can be declared in the same way as any other variable, but with an asterisk symbol. You see, when C++ having other, other data types, some of the unique, C++. We will go into that. So let's look at the structures. The structure over here. So we have our data type and the symbol, asterisk symbol. Then we have the name. Then we terminate. So we have an example here. The data type, that's the int plus the asterisk sign. Then our pointer, ptr. Then our semicolon. Then we move on to the assigning address. Now the address of operator that you can see on the screen, the end symbol, determines the address of any variable in C++. Determine the address of any variable in the C++. Now you can look at the example over here. We have our data type, that's the int, the variable, the value equals to the no value, then semicolon. Then we have another example. The example here, int, the asterisk. Then we have our pointer equals to the the address of operator here. Then the variable. Then put a semicolon there. Then we go to differentiating a pointer. It says the process of accessing the value present at the memory address pointed by the pointer. So it's the process of accessing the value present at the memory address pointed by the pointer. So we have an example here. The int, our data type, asterisk, then the pointer equals to the variable with the address of sign. Then go to our second line. We have the cout, the less than signs. Then we put our pointer there to to refer to the other variable. Now we move on to the diagram of the differentiating a pointer. You can see the diagram over here. We have the address of the pointer variable. Then we have the second one, have the value, then the address. So we have the pointer and the variable. So you can see the arrow, You have the address of the pointer variable. Then we have the value of the variable, the VAL. Then we have the address of the variable. Okay, that stores that is stored at the pointer. Now we move on to modifying modifying a pointer address. Now, a pointer can be modified to point to another address if it's of the same type. A pointer can be modified to point to another address if it is of the same type. You can see our example here. We have int, our data type, then we have our pointer equals to the address of symbol, then we have our variable. Then we have our pointer again on the second line equals to the variable there. So it means this pointer can be modified to point another address that are of the same type. You can see here. Now we move on to another example of the modifying a pointer address. You can see our usual code. The hashtag include, then we have the iStream. Second line using the name std, namespace std. Then we have int main as our function. Then in our function we have the data type that is sorry, our data type that is int, and our value equals to 5. Then our value b equals to 2. Then we have the second line, we have the int as a data type, and pointer equals to the variable that we want to reference it. No, sorry, want to want to modify the pointer address here. Then we have our third line, we have the cout, the less than sign. Then we put in the pointer to to assign yeah, to assign the value. Then we have our end line there. Then when it comes to the fourth line, we have our pointer equals to the value. Then cout, then the pointer, then we have return 0. Then when finish, we terminate it, execute it, sorry. Then we move on to data size of a pointer, or data size of pointers. So one, the equal data size for all pointers are based on the operating system and the CPU architecture. So the equal data size of all pointers are based on the operating system and the CPU architecture. So we have the 8 byte for a 64-bit system. Then we have 4 byte for a 32-bit system. Then we move on to the example of the data size. So yeah, our usual code, the include iStream using namespace std, our function. Then when you look at the function inside, we have our data type here, we have int, then our pointer to point the value. So we have pointer 1. Then we have another another data type, that is the character. Then we also have the pointer 2. Then we go to our cout, and you can see the size of. So this size of makes determine the size of the value. Then we have our end line. So another one, cout. Then we have the size of pointer 2. Then our return 0. So this is clearly to show you that the size of will make you know the size of the value that the pointer is declared. Then we move on to our special type pointers. Special type pointers. Now one we have word pointers. Word pointers. Now it says it contains random memory addressed. It contains random memory address that may or may not be valid. That may or may not be valid. So it contains a random memory address that may or may not be valid. Then we have our null pointers. The null pointers point to no valid memory location, but null. Do you get it? So the null pointer point to no valid memory, but it's null. Then initialize a pointer that did not need a memory address pointed to. And you see the example over here. So it's pointing to null. Then we move on to our special type pointers. No, we are continuing. So we have another one is the void pointers. The void pointers. So the void pointer points to value with no particular type. The points to value with no particular type. Then the fourth one is we have the dangling pointers. Dangling pointers. The dangling pointers point to earlier valid address, even though referenced memory address is erased. So the dangling pointers point to earlier valid address, even though the reference memory, the reference memory address is already erased. Okay. Okay. Now move on to reference. On to reference. Now a reference works as an alias. Okay. A reference works as an alias for an existing variable, providing an alternative name for it and allowing you to work with the original data directly. So that's how the reference is. It works as an existing variable, providing an alternative name for it. Then it allow you to work with the original data directly. So that is the reference. Now we move on to reference versus the pointers. Reference versus the pointers. Now a pointer, so we are looking at the differences. Now a pointer allows you to pass potentially large amount of data around at low cost. The pointer allows you to pass potentially large amount of data around at low cost. So explanation is, instead of copying the data, we simply pass its address as a pointer value. So that's easy to understand. Okay, now we move on to creating a reference. Creating a reference. And you can see the n symbol there is used to create a reference. Now I know most of you are confused right now because the end was used as the assign of operator. Now why is it that we have the reference, the end symbol as the reference to create a reference? Now the symbol does not make only one, only one code, used for everything. So the symbol has many, many uses. So here we have the reference using the n symbol to create a reference. I hope you understand. Thank you. Then we move on to the second line, that is the t and the reference equals to the variable. So we have an example here, that's the data type, that's the int, then the value in the variable, that's the x equals to the value. So we have int x equals to 10, that's the value. Then you can see you comment it, then you have the reference is the ref is a reference to x, so the x is the reference. So then we put our data type there and our symbol, then the ref equals to x. So it means the ref is a reference to the x. So wherever you put the ref or the reference there, its value is equals to the ref. The x value is equals to the ref. Then we move on to Application of reference. Application of reference. Now, one, we have the passing argument by reference. Passing argument by reference. I can see in the example here, we have our function as the int main. Inside the function, we have our data type. Then the value indicates as reference. Then equals to our variable or our value. Then you can see at the downside of the data type, we have the modified value, that is the x. Yes. Then we have void modified value, so the int, then the reference x. Then see our comment, we have modifies the original value, that the x equals to 20. Now we move on to another example of the application of reference. Then we have the returning reference from function. Returning reference from function. And you can see the int, now data type, you can see it here. Then you can see the get marks. Yeah. Then inside that get marks, we have the our now int, then the reference, another data type, then our reference. Then you can see our comment, we return the larger of the two numbers. Then so we return the a greater than the b. So you can see the example here. Now we move on to the properties of reference. Properties of reference. Now one, we have, you can access a reference with exactly exactly the same syntax as the name of an object. So that's one. Then two is, a reference always refers to the object to which it was initialized. So the reference is always refers to the object to which it was initialized. Then the third one is, there is no null reference. There is no null reference. Now we move on to arrays. Now, an array contains multiple objects of identical type stored sequentially in memory. Now the arrays contain multiple objects of identical types stored sequentially in memory. Now we have the individual objects in an array are called the array element or element. Okay, they are called the array element because element will be so the individual objects in an array are called the array element. So simply, the array helps you to store many values or variables inside one. Okay, make you to store more than one value inside a variable. Yes, that's what I was trying to say. Make you to store one or more values inside a variable. Now the third one is, the array element can be addressed using the index or script. So you get there. But I have to say, I'm so sorry. My IDE has some problems, so I'll just be going through step by step and showing you how the program is. So we have defining arrays. Now when we have the syntax, I can see example under the syntax, we have the type name, then we have the size. So the type name, then we have the size. So then our semicolon. So that is the array name. And you can see that is the array name. So example is, if we put our data type there. So you can see the float, data type, the float, and then the array, then the value, the amount of value you want to store inside the data type or the variable. Then you can see the array. Then we have the data size. The data size. Then you can see we have 10 asterisk, the size of, then we have the data type over there. So like I said earlier, the data type will show you the value, the size of that data type. So you can see the equals to the 40 bytes. So that's the size of that data type multiplied by 10. Means the size of that data type was 4, now it multiplied by 10, now you give you 40. Now we move on to the index of arrays. Index of array. Now the index specifies the position of element in an array. The index specifies the position of elements in an array. Then it starts with 0, or it starts from 0. Then the second one is the subscript operator. Like you can see here, the symbol is used to access the individual arrays elements. So this operator, the subscript operator, is used to access the individual arrays element, or the individual values in the element. And you can see the elements in an array. And you have array 1, array 0, and you have array 1, 2, then R up to 9, or etc. Okay, I will move on to initializing of arrays. Initializing of arrays. Now, initializing arrays refers to defining the element it contains. Defining the element it contains, and a list of containing the value. Sorry, a list of containing the values for the individual arrays element is used to initialize the array. So we have the example here. So you can see our data type. Then we have the number of arrays that we want to store. So we have 3. Then you can see the numbers that you are storing is 3. You can put any number there. As far as doesn't the value doesn't go above the array that you put inside, everything will be fine. Now we move on to initializing of arrays. The example. We move to another example, the diagram. Now you can see, as I will zoom in, and you can see over here we have our int. Now data type, then array, and you have put 5 values over here. Put 5 over here. So that means you are storing 5 values. So you can see 2, 4, 6, 2, 4, 8, 12, 16. And you can see down here, the arrow pointing down here, you have array, then you have 2, 4, 8, 12, 16. And you can see. So I'll zoom out a little bit. Then we move on to accessing arrays. Accessing arrays element. Now, accessing array element refers to reviewing or viewing individual arrays items. So it refers to viewing individual array items. And you can see the structure over here. You have the array name, then the operator, then we put the index over there, the subscript operator. You can see, then put our index inside. So as example, you have the name over there. You can see. So the array name, that's the num. Then inside the subscript operator, we have our index. So we have 3 as our index. Now we move on to the dimensional arrays. Now, the arrays with. So it means the arrays will contain columns and rows. Sorry. I'm really getting off a little bit. It's like I'm speeding up. I'm sorry. So the arrays have columns and rows. Then the second one is the 2-dimensional arrays are. And you can see the bottom there. Our 2-dimensional arrays are the data type the array name. Then we have uh, size 1 and size 2. Now we move on to declaring a 2D array. Declaring a 2D array. And the first one, the 2D arrays have row and columns. The 2D array have row and column. Then it can be visualized as a table or a matrix. It can be visualized as a table or a matrix. Okay, you can see here, for example, we have our data type over there. Then we have our, array. Then we have our index over there. Then but you go to the down. You have the above has 4 rows. Then we have 4 columns. So the first one has 4 rows. Then the second one has the 4 columns. So this can be symbolized. Sorry, this can be simulated with an Excel file. So simple as that. Now we move on to the 3D, declaring the 3D arrays. Now the 3D have rows, columns, and depth. So it's a little different from the 2D. So it has rows, columns, and depth. Now you can see our int over here. Then we have our array. Then we have the first row, that's the 4. The second column, the second is the column, that's the 4. Then the third one is the 3, that's the depth. So you can see our written over here. Then it says the above has 4 rows. Then we have 4 columns and it deep. When it deeps or deep by 3, the depth is 3. Now we move on to struct. Struct, that is the structure. The struct. Now a struct, that is a structure, is a sequence of elements into bracket called members of arbitrary types. So the structure or the struct is a sequence of elements of arbitrary types. Then we can use to create user-defined data types. So you can use the struct to create a user-defined data type. You can see some example over here. You have the struct name. Then in the struct, in that user-defined data type, we have our type 1, then the member 1. Then we have our type 2, then the member 2. Because it is inside the struct, we call it member. Then we move on to another example. So you can see struct address. Then inside we have the const, that's the constant. Our data type is the character, then our name. And the second line is the int number. Third one is the constant character, that is the shoot. We have constant character with town. Then we have character with character state, and we put our all of our code that we have been doing. All of them are inside this structure or the struct. Then we have our constants. But for the constant, we will be looking at in our next videos. So don't worry if you don't understand. We'll be going there. So we have our constant, then we have our data type, that's the character, then we have our zip. Then we move on to another example. So here, our user format, our usual format. You can see hashtag include. Then we have our iostream username std. Then we have our function int main. Then inside we have our struct, so the structure, so the struct address. Then we have our constant character, the name. Then we have our int number. Then we put our return 0 there. Now we'll be moving to creating a struct variable. Now, after creating extract value must be created. So after creating extract value must be created. You can see the example at the bottom. You have the struct name and the variable name. The second one, you have the struct name and the variable name. So this is simply the struct value must be created. We look at an example of creating a struct variable. So you can see an example. We have so inside our function we have an address called Tesano. That's in Accra. So we have address Tesano, then return 0. Then move on to creating a struct variable with the definition. So a struct value can be declared with its definition. And you can see an example over here. We have struct name. Inside we have our type and a member. Type 1 and member 1. Type 2 member 2. Then outside we have variable 1 and variable 2. So it helps us to know the struct variable can be declared with its definition. Then we move on to another example over here. So we have our struct student inside the function, our struct student. Then inside we have int. Then we have our variable, that's the age. Then another data type, that is the character. Then our variable, that is the gender. Then outside the struct student we have Julia, that is another variable over here. Then we have our 10-0. Now we move on to accessing struct. A struct member can be accessed using the dot operator. So to access the struct member, you used to use the operator dot to access it. So example, we have a variable, the name, then dot, then the member, then name, so that you can access the member. Now we have an example here. Over here. So inside the function, see out, then less than sign, then Julia.age, so that we can access the member. Then we have end line, then return 0. Then we move on to assigning struct member. Now a struct member can be assigned using the assignment operator, that's the equal to. So now you can see the equal to is also known as the assignment operator. So the struct member can be assigned using the assignment operator. And you can see our example over here. We have our variable name, then dot name, member name, then assignment operator, our new value. Okay. Then move on to another example. So you can see in our function we have Julia, then that's our variable name, then our member name, that's the age. Then you can see in between them we have the dot, then our assignment operator, that's the equals to our new value. Then put our terminator there and execute. Then move on to union. So a union is a struct that holds the value of just one of its elements at one time, or at any one time. So a union is a struct that holds the value of just one of its elements at any one time. You can see an example under. You have a union U. Then inside it, you can see our data type there, two of our data types. So we have the int, then the M1, and character M2. Then you can see we go to our go to another creating a union. Creating a union. So a union is just like other user defined data type. So a union have to be defined before we can use it. A union have to be defined before we can use it. You can see example under. So we have union, then we have the union name. Then inside it we have the type 1, the member 1, type 2, member 2. Then you terminate, then execute. Then we go to creating a union. Creating a union. So you can see our example over here. Inside a function int main, we have the union and the union name, that is the student. Then inside we have our data type, then our variable, the int age, then the character gender. Terminate, then we execute. Then we move on to creating a union variable. Creating a union variable. So after creating a union variable must be created. After creating a union a union variable must be created. So like how we did with the sorry how we did with the struct. So that's how we're going to do with the union. So you can see union name, then the variable name, and terminate. Then we have the union name, then we have the variable name. So we move on to an example. So you can see now function int main. We have the student, then we have Julia. So the student is the union, then we have our union name, that is the Julia. Then return 0, it terminates, then execute. Then we go to creating a union variable with definition. Creating a union variable with definition. Like you can see, a union variable can be declared with its definition at the same as the structure. So you see the example over here. A union, then we have the union name. So type 1, then type 2, member 1, member 2. Then outside we have the variable name. Terminate, then execute. So move on to example. So now we have our union inside the int main. So you can see our union, then you have the union name. Put there. Inside we have our data type and our variable. So then outside we have our variable name, like the Julia, then return 0, then terminate and execute. Now we move on to accessing union. So a union member can be accessed using dot operator. So the union is like simply, it simply equals to the structure. How everything does, how everything it give us. That's how the union also use. So you can see we are trying to access a member of the union using the dot operator. So we have the union variable, then the dot, then the member. So we put an example over here. So you can see the cout. So we have the union variable, then you see our end line over there, return. Then you go to the assigning a union member. A union member can be assigned using the assignment operator, that is the equal to. Then all members share the same memory. Then 3 is the only one element can store a valid value. Only one element can store a valid value. Then we have accessing value through other variable may lead to undefined behavior. So accessing a value through other variable can lead to undefined value. Then you can see example at the down there. You have the union, a variable dot number one equals to the value. Then move on to an example. Sorry, go to an example. So we have dealer.age, that's our union name. Then I have our variable, then equals to the value. Then we have the struct versus the union. Struct versus the union. So first is the struct. So struct one, it allocates the memory for each member variable sequentially. Allocate the memory for each variable for each member variable sequentially. Then two, the size of the struct is the same of the size of its members. That's including the padding for alignment. So the size of a struct is the sum of the sizes of its members. Now the third one is the members can be accessed independently at any time. Can be accessed independently, or individually at any time. Then we have the fourth one is we use to group, or it is used to group related data of different types. Used to group different related data of different types. Now we move to union. Move to the union. So the union one locate the memory only for the largest member variable. So it allocates memory only for the largest member variable, and all members share the same memory location. Like the struct also, all members share the same memory location. Now the two is the size. The size of the union is the size of its largest member. So the size of the union is the size of its largest member. Now the third one is only one member can be active. So only one member can be active at a time. So they used to save memory when only one of several members is needed at a time. So only one member can be active at a time. And used to save memory when only one of several members is needed at a time. Now move on to enumeration. Enumeration. So an enum, that is enumeration, is a type with a set of named constants called enumerators. So enumeration is a type with a set of named constants called enumerators. Now it holds a set of integer values specified by the user. Then the third one is it is possible, or the possible value are named and called enumerators. Now we move on to sorry. Now we move on to enum class, or enumeration class. And one, it uses classes for defining enumerations. So you can see example over there. We have enum class color. Then we have red, green, and blue. Now the second one, it defines an enumeration called color. Now enumerators are the red, the green, and blue. So the enumeration is called a color. You can see above the example above there. Then the enumerators are the red, the green, and the blue. Now we move on to plain enumeration. Plain enumeration can be unnamed. It says unnamed plain enumeration are used when a set of sorry Okay. Now when a set of integer when a set of integer constants are needed rather than a type to use for variable. Now it says no unnamed plain enumeration are used when a set of integer constants are needed rather than a type to use for a variable. Now we move on to the unnamed plain enumeration. You can see some example over here. So inside our function int main, we have the enumeration or then we have the enumerators. You can see the enumerators. We have red equals to 1, blue equals to 2, green equals to 3. Then our second line we have our C out, so red. So if we execute it, so the red will going to give you a value of 1. The red will going to give you a value of 1. Now move on to the blue. When we execute it, we give it a value of 2. Then the green also give you the value of 3. So thank you. That is our end of our video, and I hope whatever we went through really understand it well. And if you have any questions, just give your ideas inside the comment and I will reply you soon. Thank you very much and see you again.